All right, let's simplify some rational exponents. Jasmine, I suggest you follow along with me. Okay, we're just gonna do a bunch of examples for you guys. This is from worksheet 6. If you have worksheet 6, these are all the examples from worksheet 6. Here we go. 125 to the 1/3 power. What you need to remember about exponents that are fractions is that they're basically radicals in disguise. 125 to the 1/3 power is the same thing as 125 to the 1 power inside of a radical that has an index of 3. Okay? So the number here, the denominator is the index, the number on top is the power. 125 to the 1/3 power. Okay? And now what you got to figure out is what is the number that you multiply by itself 3 times to get 125, and that number is 5. That is your final answer. Because 5 times 5 times 5 is 125. Easy? Okay, let's try another one. Number 2, 64 to the 1/2 power. Once again, just like number 1, remember in a rational exponent, the numerator is the power, the denominator is the index. So 64 to the 1/2 power is basically the square root of 64. Because it's 64 to the 1 power with an index of 2. And that's a pretty simple one. What's the square root of 64? 8 is your final answer. All right, let's keep going. Let's do as many as we can. Number 3, 7 to the 1/2 power times 7 to the 1/2 power. It's a pretty simple one. In this case, what you need to determine is it easier if I change it to radical, or is it easier if I just leave it like this in rational exponents? Okay. Can I combine these two together? Do they have the same base? Yeah, right? They have the same base. X squared times x to the 3rd. As long as they have the same base, I can add the exponents, and it's x to the 5th power. Same thing here. They have the same base, so I can multiply them times each other, keep the same base, and add the exponents. Simply add 1/2 plus 1/2. What is 1/2 plus 1/2? Kevin? 1/2 plus 1/2. 1/2 plus 1/2. Come on, come on. Let's get it. It's 1. Thank you. So it's 7. You can turn it into a square root of 7 times the square root of 7. At the end, you're going to end up with 7 either way. All right, let's try another one. Number 4. 11 to the 1/3 power times 11 to the 1/3 power times 11 to the 1/3 power. Again, decide, is it easier if I do it like this or if I change it to radicals? Okay? As long as they have the same base, you can just go ahead and do it like this. You don't need to change it to radicals. They have the exact same base. 11 to the 1/3 times 11 to the 1/3 times 11 to the 1/3 is 11, because the base is the same. And then just add all of the exponents. 1/3 plus 1/3 plus 1/3 is 1. So it's 11 to the 1, which is 11. You can turn it into a radical and then multiply it. You'll end up with the same answer. All right, one more. No, actually like 7 more. Number 5. 12 to the 1/3 power times 45 to the 1/3 power times 50 to the 1/3 power. Do they have the same base? Not in this case. So I can't do this. I'm going to have to switch it into radical form. So I'm going to put this in radical form. Remember, the numerator determines the power, the denominator determines the index. So it's 12 to the 1, and the index is 3. This is the cube root of 45. The index is 3 again. And this is the cube root of 50. The index is 3 again. These all have the exact same radical with the exact same index, so I can now multiply them by each other. Okay, 12 times 45 times 50, and put them all under the same cube root symbol. I'm actually not going to multiply them out. I'm just going to write it as 12 times 45 times 50. Why not? Because afterwards I need to simplify them still. So I'm just going to go ahead and simplify from here. Okay, let's make a factor tree for 12. That'll be 4 times 3, which is 2 times 2. Okay, so 12 is 2, 2, and 3. Let's make a factor tree for 45. I'll do it over here. 45. What makes 45? 9, 5. 5 is done. 9 is 3 and 3. Let's make a factor tree for 50. That's 2 and 25. And 25 is 5 and 5. So what I have inside of my radical is 1, 2, 3, 3 2's. 1, 2, 3, 3 3's. And 1, 2, 3, 3 5's. Now I can simplify that. Remember, the index determines what you're looking for. You're looking for groups of 3. This means that you're looking for groups of 3. So there are 3 2's, 3 3's, and 3 5's. How many groups of 2's are they? Just 1, so there's only a single 2. How many groups of 3's are there? Just 1, so there's a single 3. How many groups of 5's are there? Just 1. That's your final answer. Just go ahead and multiply it out. 2 times 3 times 5 is 30. That's your answer. That's an easy one. Got it? All right, let's keep going. When you guys are watching this video, you guys that are here and you guys that are watching it, pause it. I'm going fast, so you guys can pause it and do it again. That's the advantage of a video. All right, number 6. X to the 4/3. Oh, this one is not simplifying. It says write it in radical form. So change this from exponential form to radical form, which is basically what we've been doing.
Is that what sheet says?
Yes. Write this in radical form. That should be pretty simple now. The numerator determines the power. The denominator is the index. So write it as a radical. The index is 3. The base is x. The power is 4. That's in radical form. Number 7. Let's continue up here. B to the 1/5. Again, put it in radical form. The numerator is the power. The denominator is the index. So this is the 5th root of B. Number 8. M to the 2.4 power. Okay. That's a decimal. But a decimal is basically a fraction in disguise. This is a fraction. 2.4 is a fraction. 2.4 means 2 and 4/10 because it's in the tens place. Change that 2 and 4/10 to in an improper fraction. So 10 times 2 is 20. 20 plus 4 is 24. So it's 24/10. Simplify it. What is 24 over 10 simplified? 12 over 5. So then your exponent is really 12 over 5. And now I can write it as a radical. The numerator is the power. The denominator is the index. So it's the 5th root of m to the 12. All right, keep going. Let's do 5 more. Number 9. Z to the 2/3. Pretty simple. The denominator is the index. The numerator is the power. Easy, easy, easy. Number 10. All right. It says in number 10, 11, 12, 13 to change it from radical to exponential. So now we're going in the other direction. Okay. Radical x cubed, and I want to write that as an exponential. Any radical is an exponential. Any exponential is a radical, right? They're just equivalent to each other. The base is x, and you are raising it to some fraction. The numerator is the power here, which is 3. The denominator is the index here. What is the index here?
2.
Not 1.
2.
2. That's a square root, right? X to the 3/2. 11. The cube root of 2y squared. Right, if there's more than one item inside of your radical in your expression, there's more than one item. For example, there's a 2 and there's also a y squared, then you have to do each one separately. Okay? Let's worry about the 2 first. What is the power of 2 here inside of the radical? 1. So the alright, so 2y squared, and we're taking the cube root of 2y squared. Whenever you have multiple items inside of the radical, you gotta break them up, do each one separately. So for example, just look at the 2 right here. What is the power of this 2 right now? 1. So the power of the 2 is 1. That means that if I write it in exponential form, it's gonna be 2 to the some kind of fraction. The numerator is gonna be 1, and the denominator is going to be 3. And the y squared is going to be separately. It's going to be y to the 2 over, and that is that in exponential form. All right, number 12. We have the square root of the quantity 6a to the 4th power. Notice that this one has parentheses around the 6a. This one does not have parentheses around the 2y. Okay, that means that this 4th power is for both the 6 and the a. Okay, so what we're going to do here is do the same thing. I'm going to leave it inside parentheses as 6a. Raise it to some kind of power because I'm changing this rational expression, this radical to a rational. The numerator is 4. That's the power that they gave me here. And the denominator is whatever the index is here. What is the index here again? 2. So what I have is 6a to the 4/2 power. 4 over 2 is just 2. So what I have is 6a squared. And now I can finish it by just squaring both of them. Square the 6, square the a. You get 36 a squared. And done. All right, last one, number 13. Let's erase these right now. Okay, number 13. The 4th root of b all to the 3rd power. The 4th root of b all to the 3rd power. There's a lot of there's multiple ways you could do this. Okay. First, what I want to do is turn this radical expression into a rational expression. So this inside the parentheses, there's still a 3 outside, so I'm not touching that. I'm just worrying about this. As a rational, it would be b to the 1/4 power, right? Because the power of b is 1 and the index is 4. And now I have b to the 1/4 to the 3rd power. The rule for a power of a power, whenever you have a power and you raise it to another power, multiply the exponents. So this one will be the x to the 8th power. Same thing here. Multiply the exponent. b to the 1/4 to the 3rd will be the same thing as b to the 1/4 times 3, which is b to the 3/4. That is the same as